Well, hello AP Statistics students. Made a video especially for you about BinomCDF versus BinomPDF and binomial distributions. So I made up a question on the probability a quarantined AP Statistics student has showered on a randomly selected day is 1 in 4, 0.25. Maybe that's a little high of a probability, but I just made it up. Assume that one student showering is independent of other students showering. So we have independence. First thing, before we answer this question, maybe I'll just add it in here. What makes this a binomial random variable? Show that it is binomial. There we go. So what makes this a binomial random variable? And then we'll look specifically at how to tell if you should do BinomCDF or BinomPDF on your calculator. So to be binomial, we have this bins, so binary. This is a binary situation. It's either they've showered or not. Shower or not. So there's success. We'll define success as shower, and failure as not showering. So there should be clearly defined success and failure. Independence, we were told to assume that one person showering is independent of another, so that's good. If that condition wasn't met, then we always have the 10% condition. If, for instance, you're sampling without replacement, then you really don't have independence of observations, but it's not a big deal as long as your sample is less than 10% of the population. But we're told right here that we have independence. And then N, do you have a fixed number of trials? Well, looking at the question down here, we do have a fixed number of trials, 8. If there isn't a fixed number of trials, if it's like how many students do you have to sample before you get your first success, or until your first success maybe is on the 5th student that you sample, that would be geometric. Maybe that's another video. And then for bin, so N is number, and then the probability of success, the success probability, and that's provided in the problem as a quarter. So this is a binomial situation. Okay, so let's actually get to the meat of this video, the meat being when can you tell and how do you use BinomCDF versus BinomPDF on the TI-8384. So let's check out our first question. What is the probability that exactly 2 out of 8 students will have showered that day? So again, our number of successes is 8, and this 2 is the probability we're actually looking for. Probably, though, the most important part of all of this is this term right here, exactly. If you have this term exactly, then that tells you just want one particular binomial term, exactly one term. So that's basically using the binomial theorem. So like 8, choose 2. You have 8 people, you're choosing 2 of them. And your probability of success is a quarter. We want 2 of those. Your probability of failure is 0.75, and we want 6 of those. This formula is on the formula sheet. The only slight difference is combinations can be written as 8, choose 2. It's not a fraction, but it kind of looks like a fraction. But the formula sheet uses this notation for combinations. So we could calculate this, but really I wanted to show you what it would look like to use BinomPDF. So let's transition over to my handy-dandy calculator here. And we'd have second. And if you look at the very bottom of the screen, this key press history, you can see what buttons I'm pushing if you miss something. Second vars, I'm going to hit the up arrow to find BinomPDF since it's exactly 2. Hit enter. Number of trials, there's 8 students that we randomly select. Our probability of success is 0.25, and our x value is the probability we're looking for, exactly 2 out of 8. And paste that in, and there's your answer. Now, if you're going to use this on the AP exam, if you wrote it just like this right here, you would probably get what score? Yes, that's correct, and incomplete. So, in the past, at least on all rubrics, as long as you define this as n, that's probability, and that's x, that then would be, I would call a weak E, but an E nonetheless. So the answer we get is 0.31. Now you would get the same answer if you would have done the longer way being, let's see, 8, choose, under the math button, 8, choose 2, and then 0.25, raise, whoops, I guess that'll be okay, raised to the 2, and then 0.75 raised to the 6. And we get the same exact answer. This answer, if I had a preference, I would prefer that you do this way, because that's like a stronger E right there. But again, on all past exams, both of these approaches are accepted as long as you label these different parameters there. So that's how we do that first question. That's when you have an exactly a certain number out of 8. So let's go back to the next question. What's the probability exactly 4 out of 8? If you'd like to pause this video, you can do that. So we get, clear all that, second vars, hit the up arrow. This is exactly 4. So we have 8, we have 0.25, and we have 4, exactly 4. And the answer is 0.0865. Now on average, if we have 8 times 0.25, we're expecting on average to get 2. So we had a much higher probability of getting getting exactly 2 out of 8. And our probability of getting 4 out of 8 has decreased, so it's less likely. Let me show you what a binomial distribution looks like. Here's the website Staplet using their binomial distribution applet, and I inputted 8 was the random sample of students, 0.25, and on the y-axis we have the probability, and the first question was the probability exactly 2, that was 31%, and then the one we just did I think was 4, probability of getting 4 was 8.65. So you can see at the on the x-axis here you have 0, 1, 2, 3, 4, 5, 6, 7, 8. Those are all your possibilities if you have 8 students. And then if we wanted exactly 4, you can go this way. Exactly 4 is just this one probability. So some questions you could be asked, is it appropriate to model this binomial distribution with a normal curve? Well, let me get rid of this. Plot distribution. There we go. So we'd say no. That doesn't really look nicely normal. And this basically is getting at the idea of, for a binomial distribution to be nicely normal, you'd have to have n times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. So you could tell n times p is 2. That is not greater than or equal to 10, so this is not going to be good to use a normal distribution. And this one would be 8, and that's also, that's also not greater than 10. Now maybe if we had increased the sample size, we would have gotten a nicer distribution, say maybe 80. Now we get, now we get a pretty nicely normal distribution, where our mean is 20, and that is greater than 10. 80 minus 20, 60, and that is greater than 10. So there have been multiple choice questions about that type of topic. Identify the binomial distribution based on the graph and stuff like that. So that was C. Now let's look at the other function on our calculator, BinomCDF. I know that this is going to be BinomCDF because of this very important term right here, at least 2. So at least 2, if you think about it, at least 2 means we have to do 8 choose 2, 0.25 squared, 0.75 to the 6. That's 2, but at least 2 would be the probability of 2 or 3 or 4 or 5 or 6 or 7 or 8. All these numbers are at least 2. So if we did it this way, we're going to have a lot of these binomial probabilities to calculate. I do like to write these out like this because it registers in my brain, hey, this is a lot to do. There's probably a much better way than having to do all these. Oh, sorry, shouldn't be choose 2 again. Fix that. 8 choose 3 now. 3 and a 5. But still, there's going to be a lot of these to do. So there's 2 approaches that you can do. One approach is to use the complement instead of finding all of these. It would be much faster to do the probability of 0 or 1 and then do the complement of that. So to do 1 minus the probability of 0 or 1. And that would be equal. These 2 would be equal. And that wouldn't be too bad. See if I can change these here. Get rid of some of these numbers. Didn't work so bad. So I'd have to do 8 choose 0, 8 choose 1, 0.25 to the 0, 0.25 to the 1, that's an 8, and that's a 7. Now it wouldn't take too long to do each of those individually, add those up, and then subtract from 1. To use BinomCDF though, hey, BinomCDF. BinomCDF is built so it'll calculate a probability. It'll add a bunch of probabilities for you, but you have to tell it where to stop. So rather than typing any of these numbers in, we're actually going to have it calculate 0 and 1 for us, and we're going to tell it 1, and it stops at 1. So let's see what that looks like on the calculator. So if we did calculator, if we did clear out this guy, if we did second vars, doing BinomCDF, and we have 8 trials, we have 0.25 probability, and the question is, what do we put for x here? That's the biggest number within the complement that we want. So we wanted 0 and 1, so we're putting 1. Paste that in there, and that's the probability of getting 0 or 1. But since we want at least two, we have to do 1 minus that answer. So the probability of at least 2 is 0.633. So comparing it on our Staplet binomial distribution, if we want the probability of at least 2 successes, that's shaded in the probability of at least 2 successes. And then right here, 63.3% is the probability that we get from 2 to 8. So that's a binomial distribution, kind of visualizing what's going on there. And let's look at the next one. If you'd like to pause this video, I'd encourage you to do that to see if you could figure out this probability at least 3 out of 8 who have showered on a randomly selected day. Alright, so on the left side in blue, I have, if I really want to do a lot of work, this is how I would do it before graphing calculators come along. I need the probability 8 choose 3, the 8 choose 4, all the way down to the 8 choose 8, and then even when I have all those, I'm not done, then I have to add them together. That would be a lot of work. Usually on the AP exam, they wouldn't ask you to do all those. They would give you one a little more accessible, like the previous one, where you could just do a complement. And the complement's what I want to talk about. Over on the right in red, we have the probability of 3, 4, 5, 6, 7, 8. That's at least 8. So we could do the probability of 0, 1, 2, and then subtract from 1. 1 minus the probability of 0, 1, 2 would be equal to the probability we're looking for. And that might help you read it that way, because then it can tell you when you're using BinomCDF, you have 8 as your n, you're going to have 0.25 as your p, and the x is the highest number of successes you want it to calculate, and the highest number we want it to calculate is 2. And then we do 1 minus that answer to get our answer. So let's check that out on the graphing calculator. So we would have Binom, second vars, BinomCDF. We have 8 trials, 0.25 probability. And the x value we want, since we're doing at least 3, we need a 2 there. So it will calculate for us, this value is 0, probability of 0 out of 8, 1 out of 8, or 2 out of 8. So to get the answer we're looking for, we would have 0.321 is the probability at least 3 out of 8 have showered on a randomly selected day. Just to verify with Staplet, at least 3 out of 8, go. And there's our answer, 32% that we had from the calculator, 32%. All right, let's look at another example. So on this one, should we use PDF or CDF? Well, another key word is at most. At most is another word that identifies we don't want just one particular outcome, but we want a range of outcomes, a continuous range of outcomes. So we should be using CDF here. So at most 3. At most 3 out of 8 would be, well, 0, 1, 2, 3. The most is 3. So in this problem, we don't have to use the complement. We could just do BinomCDF, where n is 8, p is 0.25 still, and x is 3. Again, making sure that you label these n, p, and x. So using our graphing calculator, again, not have to subtract from 1. It's not a complement we're looking for. Going to our graphing calculator, the answer we should get is, let's clear all that stuff, second vars, BinomCDF, 8, and we're doing at most 3. So the answer we get is 0.886. And just to verify on Staplet, if I may, at most 3, that would be at most 3, go. And notice the shading here is 0, 1, 2, 3, and the probability is 88.62. So that's at most 3. So probably the biggest idea, if I were to summarize some things, verbally, what to look for in questions. If it says exactly blank out of blank, then you should be using BinomPDF. If it says at most or at least, either of those, of blank out of blank, at most 2 out of, out of 3, or whatever it is, then you use CDF on your calculator. And then the last thing is make sure you label N, P, and X if you're going to do that on the AP exam. Hope you enjoyed this video. See you next time.